Dear students, we are in 5.9 miscellaneous exercise, okay, and among 23 questions, we have completed 17 questions, okay, up to last class, and the remaining 6 questions are there, 18 to 23. Let us try to finish in this class, okay, then we are going to finish this exercise, okay. See what they have given in question number 18. If f of x is equal to modulus x cube, okay, what you are doing here, any number you are making first modulus, then you are making cube. Show that f double dash x exists for all real x and find. That means f double dash x means what? Second order derivative. Okay, second order derivative we have to find. It should be exist and it has to be find, like he is asking. Okay, let us find. It is existing. Okay, see how I am writing. F of x is equal to modulus of x cube value. How it gives? Minus x cube if x is less than 0, x cube if x is greater than or equal to 0. Is it correct? First you see f of x value minus x cube is coming when x is less than 0, plus x cube when x is greater than 0. See, this is f of x value. When these values are there, we can derive, that's all. First derivation, second derivation we can do. Because see, these are derivatable, no? These are derivatable only. You have received the answer. These are derivatable. Okay. See how I am doing. F dash x is equal to d by dx of minus x cube, that is equal to minus 3x square. Okay. Then f double dash x is equal to d by dx of minus 3x square. Why double dash? See, f dash x means a single derivative. First, this function we are doing. Double dash means this result again you are going to do d by dx, that is equal to minus 6x, where x is less than 0. Okay. Then write down for again for this also, when x is greater than or equal to 0, f dash x is equal to d by dx of x cube, that is equal to 3x square, comma f double dash x is equal to d by dx of this 3x square, 6x, where x is greater than or equal to 0. Okay, that's all. Why? Because see, function value is coming like this only, na? When x is greater than or equal to 0, x cube will come. When x is less than 0, then minus x cube will come. After coming out of function, you are going to do derivation, like you are going derivation. That's all. That means these are derivatable. Okay. First, last one sentence you write. Derivatable f of x is, see, f of x is derivatable and the values are minus 6x and 6x accordingly. Okay. F of x is derivatable and the values are minus 6x and 6x accordingly. See, minus 6x when x is less than 0, plus 6x when x is greater than 0 accordingly. Okay. Let us go for 19th question. Okay. See the 19th question. Using the mathematical induction, prove d by dx of x power n is equal to n into x power n minus 1, where n is capital N, natural number. Okay, all positive integers like they have given. All positive integers means this only. Okay. All positive integers means you see 0 also you can take, but okay, let it be. We will take this only. Okay. D by dx of x power n is equal to n into x power n minus 1. Okay. See how to proceed further. Mathematical induction we know very well. First of all, this is like equation. This equation we have to take as proposition Pn. Okay. You see P of n. Now I am taking. Let P of n. Column you write. No, don't write equal to. Why? Because equal to is there already. Proposition n is equal is d by dx of x power n is equal to n into x power n minus 1. Okay, this is proposition. Okay, this proposition is true, like you have to see, you have to show. How to show? First of all, p of n is there, then you take p of 1. Okay, then p of 1 I am taking, you see, p of 1 colon LHS is equal to, see, p of 1 LHS I am taking. Okay, LHS is equal to RHS if you show automatically. Okay, see, I am writing how. LHS. LHS means you see n means n, 1 means 1. D by dx x power 1. D by dx x power 1. That is equal to dx by dx, that is equal to 1. Okay, see, d by dx x power 1 means 1 only, na, x only. Dx by dx, that is equal to 1, that's all. Okay, this is LHS. Write RHS also. See how I am writing RHS. RHS is equal to, see, when n is there, n. When 1 is there, 1. 1 into x power 1 minus 1. That is equal to 1 into x power 0, that is equal to 1. Actually 1 into 1, that is equal to 1. Okay. Now you tell me this is 1, this is 1. LHS is equal to RHS. Shall we write? Definitely we can write. Write down. P of 1 LHS is equal to RHS. P of n is true for n is equal to 1. Is it correct? First you see. See, don't write P of 1 is true. P of n is true. Proposition is true, but where at n is equal to 1. Okay, like that we have written. Next we will go for P of k, and we will assume it as true. Okay, true we have written, assume it as true. Let us go for P of k. P of k colon, here directly you can write what we can say, LHS RHS, but assume true like we have to take. Okay, see how I am writing P of k. P of k, you see, P of n plus k you have to write d by dx x power k. D by dx x power k. Okay, when n is there, where n is there, there k you have to write. That is equal to k into x power k minus 1. Is it okay? Definitely okay. See, this you have to take as true. Assume pk is true. Write down. Assume p of k is true to prove p of k plus 1 LHS is equal to RHS. See, P of k LHS is equal to RHS is true, like you have to assume. P of k you have to assume. See, one you have to prove, one you have to assume, second you have to prove. P of k plus 1. That is the process of mathematical induction. One we have proved P of 1 and P of k we have assumed true, like. Now we have to prove P of k plus 1 LHS is equal to RHS, like. Okay. See what I am writing. I am writing now P of k plus 1. Okay, see. P of k plus 1 comma LHS is equal to, see here we are proving means LHS RHS separate we have to write and I have to prove LHS. You see where k is there k plus 1 you have to write down d by dx of x power k plus 1. See when k is there k, when k plus 1 is there k plus 1. But this you can also write this like this, you see d by dx of x power k into x, not k, x you write. Is it okay? First you see why, because x power k plus 1 is equal to x power k into x power 1. Here 1 is there. Now if you multiply bases are same, x power k plus 1 will come. Okay. Now you see this is like what we can say, derivation of multiplication, uv, u into v, v du by dx, like that you write. Write down. Shall we write here? Okay, v d by dx x power k plus u d by dx x. Is it okay? v du by dx plus u dv by dx, v du by dx plus u dv by dx. Okay. Okay, see now what will happen. That is equal to, see still we are in LHS only, p of k plus 1, RHS have not gone. See d by dx x power k value you are having, you see here. This you repeat. Copy, see d by dx x power k, x into d by dx x into d by dx x power k, d by dx x power k, this value is there, you have assumed it as true. Okay, write down k into x power k minus 1 plus x power k. Why? Because see d by dx of x is 1 only, 1 into x power k, x power k. Okay, again you write, you see here x power minus 1, x power plus 1, x power minus 1 is there. You know, so how can you write this? You see I am writing x power 1 into k, I have taken top, x power k divided by x power 1 plus x power k. Is it correct? First you see why, because x power k minus 1 is there, if you multiply automatically see plus 1 minus 1 are going to get cancelled. Like that also you can write directly, you need not write this much steps. You see here you are multiplying k, you have taken common, you are multiplying x into x power k minus 1. Here x power 1 is there, minus 1, minus 1 plus 1 going to get cancelled, x power k will come plus x power k. You see x power k common you can take common. If you take x power k common, k plus 1 will become and x power k will come. Is it okay? First you see k into x power k plus 1 into x power k, k into x power k plus x power k. Okay. See this is p of k plus 1 LHS. Okay. Then I am underlining, you have to prove p of k plus 1 RHS also. I am writing RHS. RHS is equal to RHS for p of k plus 1. We are doing p of k plus 1. Okay. P of k plus 1 RHS. See p of k plus 1 RHS means p of k RHS you have to copy, and wherever k is there k plus 1 you have to write. See here k is there, write down k plus 1 into x power k plus 1 minus 1. Okay, that is equal to k plus 1 into x power k. Why? Because see plus 1 minus 1 are going to get cancelled. Okay. Now you see here both are same. Write down finally p of k plus 1 LHS is equal to RHS. Hence p of n is true for all values of n. Okay. Like that you have to write it. P of n is true for all values of n. See, for 1 is true, for k is true we assumed, for k plus 1 we have proved. For all values true, like you have to write and close. Okay. Let us go for 20th question. Okay. Okay, see the 20th question. Okay. What they have given, first let us understand. Using the fact sin of a plus b is equal to sin a cos b plus cos a sin b, and the differentiation obtain some formula for cosines. Okay, see, fact means one result or equation is there. This we know. Sin of a plus b is equal to sin a cos b plus cos a sin b. Sin of a minus b is equal to sin a cos b minus cos a sin b. Okay, if this is the case for cos of a plus b is equal to cos a cos b minus sin a sin b. See, for cos, first two terms cos will come, second two terms sin will come, second term. Okay, but if plus is there, minus will come, minus is there, plus will come. Cos of a minus b means cos a cos b plus sin a sin b for cos. For sin, plus is there, plus, minus is there, minus. For sin cos sin will come. For cos sin will come. Okay, this analogy we know very well. Okay, what they are asking, this formula and the differentiation. You find some formula for cosine like this. See, simply you differentiate this and find cos formula like. Why? Because if you differentiate, cos will come. D by dx sin x is cos x. Okay, if you differentiate this, automatically cos formula is going to come. That formula is asking us to write. Okay, let us write. We know this how to write and all. Okay, see how I am writing, differentiating both sides. Okay, shall I write formula once again? Okay, see, I am writing formula. Sin of a plus b is equal to sin a cos b plus cos a sin b. Okay, see, I am doing differentiation both sides. One side you cannot do. Okay, see, step I am writing how. D by dx of sin of a plus b is equal to d by dx of sin a cos b plus d by dx of cos a sin b. Okay, is it correct? First you see, both sides I am doing. Here only one term, that is why one, but here two terms are there. Two terms separately I am doing. Q plus v like. Okay. See, while doing the differentiation, first consider a plus b as x, sin x. D by dx sin x is cos x. Write down. Cos of a plus b. Over, no. See, these are not x. If it is x, then over. But it is not x. That is why again you have to do d by dx of dA by dx plus dB by dx. Is it okay? Why? Because you don't know what is a and what is b and all. That is why you are going to write like this. dA by dx plus dB by dx. Plus is there. Okay? Same like this only you do this side also. You see, here u into v is there. V d by dx of sin x, cos a. Again, see, d by dx of sin x, you are doing, okay, one step, let me write one more step. Why? Because see, you may get confusion. Here it is okay. Why? Because nothing is there. Sin x, we have done cos x, again d by dx of a plus b. But here I don't want to write like this. I am writing, you see what I am writing. See, v d by dx of u plus u d by dx of v. Okay. Again, okay, write down. See, plus is there. That is why plus I am writing directly. Okay. See, v d by dx of u, again plus, yes, plus u d by dx of v, that means sin b. Sin b. First of all, see whether it is correct or not. You see, u into v like you take. Sin a is u, cos b is v. V d by dx of u plus u d by dx of v plus v d by dx of u plus u d by dx of v. Okay? Definitely okay. Now proceed further. See, this you need not change until last. Why? Because this is over. Okay? Then shall I write equal to and finally I will write this one? Like that also you can write. You see, RHS only I am writing. Finally we will write again this. Why? Because you can get space. Okay, see, cos b you can write down cos b into d by dx of sin a, cos a. Over, no. Why? Because a you don't know. If it is x, over. but not x. That is why d by dx of a. That means dA by dx. Is it okay? Definitely okay. Okay. Now you don't put plus. Why? Because minus is going to come. Sin A you write. Okay. D by dx of cos B minus sin B. Right one. Minus sin B over no. Again d by dB by dx. dB by dx. Okay. Now don't put plus. Why? Because again cos is there. Cos means it will come minus. Okay. Write down first sin B. Okay. D by dx of cos A minus sin A. Write down minus sin A over no dA by dx. dA by dx. Okay. Here sin is there, plus you can put cos A. Okay. D by dx of sin B is cos B. Okay. Again dB by dx. Is it okay first? You understand this term? Okay. See what I am doing now. dA by dx is there. One is plus, one is minus. Okay. See, I am taking this common. dA by dx. See how I am writing. dA by dx, if I take common, cos A cos B. Shall I write cos A cos B? Cos A cos B. But here this is minus, you see. Sin A sin B. Shall I write minus sin A sin B. Is it okay? See, these two terms over. Okay. These two terms also dB by dx is there. Again I am taking plus dB by dx common. Okay. See, this is plus. Plus 1 I want to write, then minus 1 I will write next. Cos A cos B minus sin A sin B. Okay. See, what you observe now? Cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. See, here these two are common. I am going to take now cos A cos B as common, and these two I will write in bracket. Okay. See what I am doing now. That is equal to cos A cos B minus sin A sin B. I have taken common. Why? Because both sides, here also this one, here also this one. Now if I take common, this automatically what is there? dA by dx plus dB by dx is there. Is it okay? Definitely okay. But now you bring this RHS, this side. You see RHS is what? This one. Cos of A plus B into dA by dx plus dB by dx. Okay. See, LHS or RHS equal to is there means any side you can write. Now you see what you can do now. So you can cancel out this. See, multiplication is there. dA by dx plus dB by dx, dA by dx plus dB by dx, you can cancel out both sides. If you cancel out, what will come? This will come. Cos of A plus B is equal to cos A cos B minus sin A sin B. You see, for cos, both cos will come first, then both sin will come. If plus is there, minus will come. This is the formula. Same as obtain some formula for cosine. This is some formula for cosine. You write down. We obtained some formula for cosine. Okay. Like this you write and close this question. Okay. Let us go for 21st question. Okay. See, 21st question. Does there exist a function which is continuous everywhere? That means full continuous function, but not differentiable at 2 points. Yes, is there function? You can design. You have to design this function. You see how I am designing. F of x is equal to x minus 3 plus x minus 4. Okay. See, these are two functions, or else I will take only x. Okay, let it be. Okay. See here, these are continuous functions. Why? Because there is no control. There is no control. Logical control. X is greater than something like this. That is why these are continuous functions. Whatever the value you give left side, right hand side, both are going to come same. That is why these are continuous functions. Everywhere, continuous at everywhere. Okay. Now, what is about differentiable? See, this you take as like f of x is equal to g of x like h as x. G of x is continuous but not differentiable at x is equal to 3. Okay, at x is equal to 3, numerator denominator. Why? Because the differentiation derivative division has to come. Delta x by delta x. There it comes to a problem. Okay. Then you have to take minus left hand side, right hand side positive. Then automatically one side will come negative, one side will come positive. When x is going to become this 0. Okay. Okay. This function is not differentiable at x is equal to 3. This function is not differentiable at x is equal to 4. Like this, any function you can design. Okay. If you write here 1, x minus 1, then not differentiable at 1. If you write here 2, not differentiable at 2, like that you can write. Okay, these two functions we have taken, and we will prove that these are not differentiable but are continuous. See, these are continuous like we know by virtue of our experience. That is why I am not showing continuity, but I am writing continuity. You see, function f of x is continuous at all values where x is less than 0 and x is greater than or equal to 0. See, I am writing greater than or equal to 0. Okay. Everywhere these values are continuous. This one word we have written, and we will stop continuity. Continuity we know very well. There is no logical controls. Logical controls are there means we have to see continuity. Here we need not see direct this thing only. But differentiability, let us see. See, functions, two functions are there. Okay, two functions. Total together becoming fx, gx, hs like. Both are continuous, then only this is continuous. If both are not, one is not continuous, then not continuous. Sorry. One is not differentiable, not differentiable. Both are differentiable, then only differentiable. Okay. See, here this function is not differentiable at 3. This function is not differentiable at 4, like we will show. Okay. 2 points are going to become. Okay. Differentiability of x minus 3 modulus at x is equal to 3. Okay. See how I am showing differentiability of this function. See, left hand derivative, right hand derivative, how to see differentiability means. You see what I am writing. LHD is equal to left hand derivative. Limit delta x tends to 0 minus. Okay. F of x minus delta x minus f of x divided by minus delta x. Okay, both area minus minus you have taken. Why? Because 0 minus left hand derivative. Okay. See, limit delta x tends to 0 minus. Now you write function. First you write formula, then you write function, then you substitute at x is equal to 3 means 3. This is the procedure. Okay, now I am, see, formula over, then I am substituting the function first. Function. You see, wherever x is there, x minus delta x you have written. X is there, x minus delta x I have written, then minus 3. Minus x minus 3 divided by minus delta x. Okay. Okay. Now proceed. See, this is formula, this is function. Now you write at x is equal to 3. Write down. At x is equal to 3. Again you write comma limit delta x tends to 0 minus. See, at x is equal to 3 means 3 minus delta x minus 3 modulus minus 3 minus 3 divided by minus delta x. Is it okay? See, 3 minus 3 is going to get cancelled. Minus delta x is going to come. Modulus of minus delta x. Division minus delta x. But you write limit extends to 0 also. That is very important. Limit delta x tends to 0 minus modulus of minus delta x by minus delta x. Okay. See, why 3 minus 3 is 0? Something minus 0 you need not write. Here also 3 minus 3 are cancelled. Minus delta x. Modulus is there. Bottom is minus delta x. You see what will come? Minus 1 will come. Why? Because you see, or else I will write like this. One more step I am writing. You see, limit delta x tends to 0 minus minus 1, that is equal to minus 1. Why? Because see, this after modulus, this is going to become plus delta x. Why? Because modulus will make it a plus delta x. But here minus delta x is plus delta x by minus delta x. That means both are going to get cancelled. Minus 1 will going to come. Minus 1. See, limit of a constant function, constant value, limit of a constant value. Now minus 1 has come. Okay. This is left hand derivative. Then go for right hand derivative also. Write down. Right hand derivative, RHD. RHD is equal to limit delta x tends to 0 plus f of x plus delta x minus f of x divided by plus delta x. This formula is very important. You see here 0 minus means left hand derivative minus delta x you have taken. Right hand derivative 0 plus delta x you have to take. Okay. See, this is formula. Then you bring a function. Limit delta x tends to 0 plus function x plus delta x minus 3 minus x minus 3. Okay. See, function is x minus 3 only. Where x is there you are going to write x plus delta x. Okay. Then plus delta x. You write plus delta x only. Don't write only delta x. Why? Because concept you have to know. See, this is formula, this is function. Now at x is equal to 3 you write. You substitute x. At x is equal to 3 comma limit delta x tends to 0 plus now write down 3 plus delta x minus 3 modulus close minus 3 close plus delta x. Okay. See, 3 going to get cancelled. Plus delta x by plus delta x is going to come. Okay. Here 0 you need not write. Write down again. Limit delta x tends to 0 plus delta x modulus plus by plus delta x. That is equal to limit delta x tends to 0 plus 1. That is equal to plus 1. Plus 1 you write. Why? Because now you write down. What you are going to write? LHD is not equal to RHD. LHD is not equal to RHD. Left hand derivative is not equal to right hand derivative. Therefore, modulus of x minus 3 is not differentiable. Not differentiable at x is equal to 3. Okay. This is possible only at x is equal to 3. Only 2 points you have to show. 2 points, at one point is x is equal to 3, at another point is x is equal to 4. That also we are going to show. Okay. That also we are going to show. I think we need not rub. In this only we will make it. Okay. That also we are going to show. But first pause and note down this. I am going to change the here only. Okay. It will be simple. Okay. Note down. Okay. See now. Differentiability of x minus 4 we are doing at x is equal to 4. Okay, these two are changing. See, different colors I am writing. Where earlier x minus 4 at x is equal to 4. See, we are showing differentiability of second function. 2 points we have to show. X is equal to 3 at one point we have shown. Second point x is equal to 4. At x is equal to 4, this is not going to be differentiable. Okay. See, this is okay, but here we are writing, see, here both area we are going to write 4 minus 4 minus 4. Okay. See, this formula is same, but here function is x minus 4 now. X means x minus delta x you have to write. Why? Because 0 minus left hand derivative. Okay. See here, now you are substituting 4. Write down 4. 4 minus 4. 4 minus 4. Here also 4 minus 4. Okay. 4 minus 4, 4 minus 4 delta x. That means see 4 minus 4 going to get cancelled, but minus delta x modulus by, see this is same again. Okay. Left hand derivative has come minus 1. Now come for right hand derivative. This formula is same, but here not 3. You have to write it as 4. Write down 4. X minus 4, x minus 4. Okay. See, this is formula, this is function. At x is equal to 4, again you are going to write. Write down at x is equal to 4. See, at x is equal to 4, these two values are 4. 4, 4. This is already 4. This x you are going to substitute as 4. Okay, here also. This is already 4, but x you have taken as 4. Okay, remaining all same. Okay, plus delta x will come. Denominator plus delta x is there. Both are going to give plus 1. Minus 1 plus 1 not equal. Then what you are writing here finally? X minus 4 modulus is not differentiable at x is equal to 4. Okay, same like 3, 4 also. Like this, any function you can design. Modulus x 0, x minus 1, 1. 1 at 1, x minus 1, x minus 2 at 2. Like this, any function you can design and close this question. Okay. Shall we go for 22nd question? Let us go. Okay. See, if y is equal to determinant f of x, g of x, h of x, L, M, N, A, B, C. This is one determinant. This is called y. A like y we can call. Okay. Prove dy by dx. Observe careful. We are in the differentiation. That is why dy by dx has come. First derivative. F dash x, g dash x, h dash x, L, M, N, A, B, C. See, L, M, N, A, B, C not changed. Only functions have been changed. Okay. Like that we have to show. Prove means we have to show. LHS is equal to RHS like. Okay. Now see how to proceed this question. Determinant. You see what I am doing. First I will take y only. Y determinant y I will find. Determinant y means final result will come. Okay. That result I am going to differentiate. dy by dx. See y is equal to this determinant also you can write. Y is equal to this expanded version also you can write. Both are y only. dy by dx means what? dy by dx means automatically differentiation of this expanded version. We will do expansion differentiation. That result we will box. Okay. Then we will expand this derivative of this function. If we expand this, automatically one result will come. Both expanded versions are equal, then we can say that we have proved. Okay. Like this we can do. Okay. You see what I am writing? Observe carefully. Okay. See, y is equal to see f of x into mc minus bn. mc minus bn. Okay. Minus g of x into lc minus an. lc minus an. Okay. Plus h of x into h of x. lb minus am. Is it okay? First you see. LC minus an. LB minus am. Okay. Is it correct? First you see. This is the determinant. Y. Now I will do dy by dx of this one. Okay. See how I am doing. Dy by dx is equal to. You see here. MCBN are what? These are constants. Except x and y, all are constants we know. But these are not constants. These are functions. F of x, g of x, h of x are functions. Function you can do differentiation. But constants like if constant is there, directly 0 will come. If constant as an elements are there, element will take common. See here like elements these are. Function multiplication with constant means this is element not a constant. Okay. Element you take out MC minus Bn, then f dash x. Why? Because see, d by dx of f of x means f dash x. Okay. Minus LC minus An also you take out. Then d by dx of g of x is equal to g dash x. Okay. Again you take common this plus LB minus AM. G by ds of h of x is h dash x. Is it okay? Definitely okay. Okay. See, multiplication you can write f dash x into MC minus Bn or LC minus An into g dash x. Both you can write. Multiplication is there. Okay. See, this is the case of y. Now you go for dy by dx and write down the dy by dx also. I am writing, you see, dy by dx is equal to this one. Okay. How can you differentiate both? We will do one thing. This we can take like this, okay? Determinant y and determinant y you keep. Okay, but see, both are okay, but you have to show, na? See, this I am writing like this. You see, dy by dx, but determinant. Both are same, but you have to know, na? Both are different, like until doing. Afterwards, both are same, like you can show. Okay? See, this determinant I have taken. See, first this determinant is there. That determinant you have differentiated. This direct determinant you are taking. You see what I am writing? F of x, f dash x into MC minus Bn. MC minus Bn minus g dash x into LC minus An plus h dash x into LB minus Am. Is it okay? Definitely okay. Okay, now you compare both. You see f dash x into MC minus Bn, f dash x into MC minus Bn, minus g dash x into LC minus An, minus g dash x into LC minus An, plus h dash x into LB minus Am, plus h dash x into LB minus Am. Okay, now you can write like this. D by dx of determinant y is equal to dy by dx determinant, comma, hence proved. Okay, see, you have to segregate it. D by dx of determinant y is equal to determinant of dy by dx. Both are same, hence proved, like you write and close this question. Okay, let us go for 23rd question. Okay, see the 23rd question. If y is equal to e power a cos inverse x, y is equal to e power a cos inverse x. Okay, a is a coefficient, cos inverse x is there, e is there. Here two functions are there, inverse function, exponential function. Okay, prove 1 minus x square into d square y by dx square, second order derivative. Why? Because y is this one only. Minus x, first order derivative dy by dx, minus a square into y. Without derivation, you have to multiply like this. We have to do. Okay. See, what is the logic? Such questions are comes means don't do separate. First of all, you do dy by dx. Any denominator means this. There means you transfer it to LHS side, multiply, and again you do second order differentiation. Second order is going to come again. Any denominator means you transfer. Then you make that final equation, then this is going to become equal to that question, like it is going to become normally, naturally. Okay, don't do separate. Okay, see how I am doing. You observe carefully. Okay, why you are having dy by dx, I am finding, you see, dy by dx is equal to, see, you first consider e power x, like e power x, d by dx, e power x means e power x. Write down e power x over, no, again d by dx of a into cos inverse x. Okay, again d by, why? Because this is not x, that is why you have taken, first you have considered this as x, e power x, again this you have to do. Okay, see here a is coefficient, like it will go. You see what I am writing, a coefficient and e power a cos inverse x already is there, and d by dx of No, d by dx of cos inverse x. Okay, write down once again cos inverse x. Okay. See, d by dx of cos inverse x is minus 1 by square root of 1 minus x square. Okay, you write down minus a e power a cos inverse x divided by 1 minus x square but under root. Is it okay? See, minus 1 by square root of 1 minus x square is for cos inverse x. A into e power a cos inverse x is already available. Minus by something. Okay. Now what you have to do, this 1 by square root of 1 minus x square, this you transfer to dy by dx. Multiply with this. Okay. See how I am writing. Now you write like this. 1 minus x square under root into dy by dx is equal to this one. Minus a e power a cos inverse x. Is it correct? First you see. Numerator, denominator I have transferred this side. LH side. Now I am going to differentiate both sides. Okay. Both sides I am going to differentiate. Okay. If both sides if I go u into v like both. Okay. You see what I am writing. See this differentiation if you make d square y by dx square. Write down. Comma you keep dy by dx into d by dx of 1 minus x square under root plus 1 minus x square under root d square y by dx square is equal to, we don't have space here. We have to go for bottom only. See here I am writing. You see v du by dx plus u dv by dx. This side only one function. Why? Because this is coefficient. But you see coefficient if you have taken common e power a cos inverse x you are doing means again y you are doing dy by dx. Already you have done. This result again we are writing directly. Okay. See what I am doing. V d by dx of 1 minus x square under root plus u d by dx of dy by dx. This side over both. Okay. That is equal to minus a you have taken common. Again d by dx of y. Shall I write y? E power a cos inverse x is equal to this one. Y I have written. Again you can copy this final answer here. Okay. But minus a will come extra. Minus a into this result is going to come. Okay. Okay. Proceed. See dy by dx you keep like this only. See what will come here. D by dx of root x. 1 by 2 root x. 1 by 2 root x. Okay. Again d by dx of 1 minus x square. Minus 2x. Either 1 is 0. This is x square means 2x but minus is there. Minus 2x. Minus 2x. Into dy by dx. This dy by dx already is there. Okay. You see this 2 going to get cancelled but minus x by 1 minus x square root dy by dx is there. This side. Okay. This side you see. This is simple. 1 minus x square under root but this is d square y by dx square. Is it okay? Why? Because d by dx or dy by dx is d square y by dx square. Here minus x by is there. 2 got cancelled. dy by dx. Okay. Now this side you come. Minus a you write. dy by dx value you are having dy by dx. This one. Again you write minus a e power a cos inverse x divided by 1 minus x square under root. Is it okay? Definitely okay. You see, again I am transferring this side. Okay, final answer is going to come. You see how it is going to come. Again I am transferring this to LHS side. LHS side if you transfer square root of 1 minus x square, denominator square root of 1 minus x square. Both are going to get cancelled. You see what I am doing. Minus x dy by dx. Why? Why? Because square root of 1 minus x square denominator. This is going to come in numerator. Okay? Cancel. Okay? dy by dx. Plus You see, again, this is numerator only. Minus square root of 1 minus x square, 1 minus square root of x square. This boy is going to get a square and become 1 plus 1 minus x square. Okay, d square y by dx square. That is equal to. You see, minus minus are going to get cancelled, plus a square. Again, e power a cos inverse x. E power a cos inverse x, I can shall write by. Definitely I can write. Okay. Now you see, a square y also I am sending this side, and whatever the plus item is there, that I am writing first. You see what I am writing? 1 minus x square into d square y by dx square minus x dy by dx minus this minus, it is going to become a square y is equal to 0. Is it correct? First you see, according to this, correct. Then you see what is asked us to prove. 1 minus x square into d square y by dx square minus x dy by dx minus a square y is equal to 0. Okay, this is the answer, final answer. Okay. See, we finished this exercise completely, 5.9 miscellaneous exercise, and we have finished this chapter. Then we go for application of derivatives in the next class. Okay, thank you very much.